prevention using active head restraint. These are from Abdullah Khaled and Abdullah Ahmed.
ده الحمد لله مع حد تاني يعني مش لوحده. كويس بقوا 2 3 بيساعدوا بعض في العلاج.
Thank you for opening the folder. Appreciate it. Okay. Hello everybody. It's a great honor to stand in front of you today to present the first part of our senior project. This is Abdullah and my colleague Abdullah Harris will be talking today about the design and development of whiplash injury prevention system. I'll let Abdullah start off for the presentation. So sit back and
من
relax.
زمان وتعليموا اللغة عبد وأحمد وعبد الرحمن. النطق عندهم جميل.
This presentation consists of 6 main parts. The first part is introduction, literature review, which I will be along with you, and design simulation, future work, and conclusion, which will be presented by my partner Abdullah Khaled. So let's start by introducing and defining what is whiplash. Whiplash is a term used to describe a neck injury which is related to neck sudden distortion. Symptoms of this injury varies from just slight pain in the best case scenario, but in worst case scenario it can cause a damage to neck parts such as vertebrae and soft tissues. These symptoms may last for just a few hours, and some of them may last for years, and some of them may last forever. It's an important thing to say that this injury occurs the most in rear-end collision, and even though it occurs the most for human females, studies on this field focus on human male, and as well as this study. According to Hamad Medical Corporation, in the period between 2001 and 2006, around 6,700 patients suffered from neck injury and head injury due to car collisions. And according to the National Safety Administration in USA, around 800,000 whiplash injury occurs annually, and that's cost the government there around $5.2 billion. So, since that time, since 90s, many of solutions were proposed by car manufacturers, and these solutions try to reduce the whiplash injury, but they don't prevent it. Also, they are limited to acceleration impact with 10G, which is not always the case in rear-end collision, especially. So our objective of this study is to simulate whiplash injury under 2 conditions. The first condition is with a rigid seat. And the second condition is with the same seat, but after adding absorbing energy elements. And both simulation will run under with impact acceleration more than 10G. The second objective of this study is to validate this solution through injury criteria, and the third part is to develop this design and validate it experimentally through seat testing sled and crash test dummy. So, to understand the whiplash injury, we have to give a close look to the human spine. Human spine consists of 3 main parts. We will focus on the upper parts, which is known as cervical spine. Cervical spine means neck in the normal language. Cervical spine has 4 possible motions, and according to this motion, it has different loading conditions: bending, compression, tension, and shear due to torque. So, to understand the kinematic of the injury, it's divided to 3 different phases. The retraction phase, when the occupant starts to decelerate forward or to move backward, then the restraint starts to push him forward. The point when he starts to reverse its direction of motion is the second phase. And the third phase, when the seat belt restrains the occupant and his head keeps to move due to its inertia. So, according to this 3 phases, injury criteria were established. The first one is neck injury criterion, and it is based on the acceleration difference between the head and human cervical spine. And the second one is neck protection criteria, and it is focused on the loading condition during the rear end impact. It's important to mention that adjusting of head restraint is important, and if an unadjusted head restraint may worsen the injury. Those are the most common types of solutions available in the market by car manufacturers. The first one to the left is proposed by Toyota Corporation, studying used for Land Cruiser and can be users, it got low rate comparing to the German type, which is used electric sensor to push the restraint forward, and the final type, which is one of the best type, is proposed by Swedish compression valve. It's absorb energy in addition to restrain the head. And now the story of the design will be introduced by my colleague Akol.
Wonderful. Okay, for the methodology that we used to, that we followed for the duration of this project, firstly, after a thorough understanding of the problem and what people have been doing to prevent whiplash injury in the scientific and the engineering communities, we started to build a preliminary design to prevent the injury, and then that was followed by numerical analysis and simulation of the model. Design validation, evaluation, modification of the model to obtain a final design will be considered in a later stage in the second section of the senior project. Now, our project mainly produces two actions. The first action is a rearward acceleration motion of the seat relative to the car during impact, which in effect reduces the forces felt by the human body. And in another simultaneous action, a deployment of head restraint will effectively arrest the head to prevent excessive neck rotation and thus reducing whiplash injury. Our design was designed and assembled using SolidWorks CAD software, and it's composed of three main elements. The first element is the inner slider bar, as you can see here, which is mounted to the base of the seat, and the external slider bar, which is fixed to the car floor. Mating of both elements would provide the required translational motion of the seat relative to the car floor during impact. This acceleration motion will only be activated after reaching a certain threshold, load threshold, and that will be activated by the deformation of a notch deformation element in the design. Now, as for simulation, we first started to test the functionality of the sliding motion during impact, and that was done through a less detailed model named the Hybrid 3. And the actual simulation process for our design composed of two stages. The first stage was to get an average information on the normal loading conditions during rear-end impacts, and that was done through fixing the car seats during the duration of the impact, the first 150 milliseconds of the impact. A second stage that followed that was where we implemented our design concept by activating the sliding motion of the seat relative to the car, thus reducing the injury. And now for the first stage, we obtained the following result, where we can see that the neck suffers from excessive compression and bending, and we can see that the maximum impact load acceleration of the T1 vertebrae sampling the torso of the human body and the head reach up to 6.5 times the acceleration of the gravity. With the implementation of the sliding motion, we decreased that to as low as 1.5 times the gravity, which samples a very effective solution. And here's the result. We can see that minimum loading is applied to the neck, and if we can see it again, we can see that almost no rotation of the neck is produced. With that, we achieved the design of a whiplash injury prevention system. And with that, we reduced the impact load acceleration on the human body, thus reducing the forces on the body. And also preventing excessive rotation of the head and torso. And with that, we are going in future in the Senior 2 part of the project to implement deployment of head restraint during impact, and also we will use a hexagonal deformation element proposed by research done by Dr. Saleh, our supervisor, to dam the motion of the sliding element. And I'll leave the final words to my colleague Abdullah Harris to conclude. And here's our Hybrid 3 model.
Okay. Finally, we would like to say that human body is a miracle, but if you can't make miracles, at least you can try to understand them. That's what we did in this study. Actually, we tried to understand the human motion during this impact injury and to propose a solution that restraining the head and reducing the effect of whiplash injury. Also, I hope that after this presentation, all of you will make sure that their head restraints are adjusted in the correct position. The correct positioning of head restraint is when the center of head restraint meets the center of gravity of the head, and when it's as close as possible to the occupant during his driving. Thank you.
زيادة عشان أساعد. قول له سافر زيادة
Let
عشان
me
أساعد.
just fire off one question. I might have missed it,
يا
but
رب هدوم.
do you plan to do a test bed later on and use motion capture systems to test this, to verify your
Yep.
data?
Let me answer this question. Thank you for that amazing question. As we refer back to our objectives here, the last objective will be in the second phase of the project, where we actually going to manufacture a test sled for crash test of rear-end impacts, and we'll be using the BioRID dummy, which now is the most sophisticated dummy for impact analysis. So yeah.
Thank you. Any other questions?
I have one comment and one question. The comment is about the abstract. Usually abstract, that's the first thing we read in the document. So we always try the best to make the abstract clean, neat, without any mistakes, which is not your case. Okay. Now, my question is about the slide number 6. Yes. The first formula then. Are you sure about it? Because if I check the units, you are adding acceleration in meter per second square to a velocity square, which is meter per second, meter square per second square. Are you sure about this formula?
The formula is correctly because it's established by some institute and it's used for validation of the seat design. But about the question about the unit, we have not considered it, but we may consider it in finding the final solution in the future.
Thank you. Additional questions? You have 2 minutes more.
Hello. Does this angle of chair, the angle of seat, has any impact on this impact acceleration? If you change the angle slightly, or which is the optimal angle, something like that.
Okay. Thank you for your question. The angle of the seat comes in 2 parts. The seat stiffness, that is reclining of the seat during impact, due to the loading of human torso on the backrest of the seat. Now, deformation or reclining of the seat back provides better injury prevention due to the decreased forces and the synchronized motion between the head and the torso. Now, changing the seat's angle during impact provides an acceleration motion of the human upward to the seat, which is in most cases reduces the incidence of whiplash injury. So for your question, yes, the angle of the seat, with the increase of the angle, with more reclining seats, we can improve the response of the human body to the injury. Sorry?
It means it will reduce the impact acceleration.
It will not reduce the impact acceleration, but it will reduce the effect of that acceleration, the sudden change of acceleration on the human body. It will reduce the injury.
Okay, we will finish from here and we will all drive going home, yeah? Okay, for a normal driver, how can I make sure that my head is in the right position?
This picture especially clarifies this. The head restraint has to meet the center of it, has to meet the center of gravity of the head. It's almost in the center, it's almost in the center of the head actually. The lowest, the lower line, this here in this picture, the right corner can clarify and show you.
Okay, I would like to add to my colleague Abdullah Harris. As seen by the National Highway Safety Standards and the International Insurance of Highway Safety organizations, The evaluation of an effective head restraint requires that the head restraints to be adjusted, that the top level, that the top surface of the head restraint has to be in the same level of the top of the head. So for this part, the top set has to be as minimum as possible.
Offline, thank you so much. Next group, please come forward. Our next group is on hybrid components.